Well, I always enjoy coming to relevant congresses where I can explain the work that we do, get feedback from the scientific community, but also listen to the work of other people. And it's always when you hear these um, discussions of work that you wouldn't normally study or read about, sometimes this has sort of makes great changes to how you do your own work. You think, yeah, that's a good idea, and you go back and you try that yourself. So it can be very stimulating. Well, the immune system, protects us from infections, which, at any one time there are new infections arising that could kill large parts of the population. So the immune system protects us against that. The immune system protects us against cancer also. But as the immune system has evolved, it's become incredibly sophisticated and very complex. And the downside of that is that the immune system can also cause disease. So there are allergies where our immune system reacts to foreign substances which are normally innocuous substances. But at the same time there are diseases where our immune system reacts to our own proteins, the so-called autoimmune diseases. So this can be, if the immune system reacts against proteins in your brain, it can cause multiple sclerosis. If it reacts to parts of the pancreas, it can cause type 1 diabetes. Or if it can attack proteins in the joints, this may lead to rheumatoid arthritis. And it's those diseases that I'm hoping to use our approach to treat. Well, I think the immune system, because it is so powerful, reacts to very, very low amounts of material. So we can use very low amounts of material, if delivered appropriately, to activate the immune response. But also likewise, and the immune system can be manipulated by boosting regulation through, for example, administration of very low doses of cytokines such as interleukin-2. So there are two sides to this. There's boosting the immune response through very low dose material delivery, and then there is regulating the immune response through microimmunotherapy, if you will. Well, we've known for probably 100 years now that by administering increasing doses of the material that causes allergic disease, we can actually specifically switch off the immune response to the allergen. So I decided many, many years ago to try to develop this approach to switch off the immune response in autoimmunity. We know it works in allergy. We know that the immune mechanisms that are working in allergy and autoimmunity are very similar. So why not? Why wouldn't it be possible to do the same thing? However, there are complications. It turned out that administration of the proteins themselves that cause these autoimmune diseases or are attacked in these autoimmune diseases is complicated. So we figured out a very, very long time ago that the cells that are key to these diseases, that orchestrate the immune system, the conductors of the orchestra that is the immune system, these are cells called CD4 T cells. Now, most people in the public will know these cells because they're the cells that the HIV virus attacks, right? but they're the cells that actually control your immune response. And that's why people with HIV become immune suppressed, because these cells are so critically important. Now, we figured that if we could selectively switch off the CD4 cells associated with autoimmunity, we could control the disease. And that's what we do. We design the small microfragments of the proteins that only those CD4 T cells can see. And that will be different in different individuals across the population. So we figure out which of these fragments are recognized by different people in the population. We make a cocktail of those, then we administer them to the patients in the same way as the allergists administer the crude extract of allergens to switch off hay fever or to switch off celiac disease or any other allergic disease. Well, I think first of all it works. It's looking as though the approach that we've developed is showing great promise in the clinic. Actually, we've done 3 clinical trials and the results have been very promising, I should say. Secondly, the most important point to consider is to think of this autoimmune response as, in warfare terms, a form of friendly fire, right? Where the immune system, which is designed to attack infections, is now attacking our body. And a good way of thinking of this is in terms of friendly fire. And if you read one of the US military guidebooks on military warfare, they talk about friendly fire and they say how to avoid it. And the best thing to do to avoid it is to train your troops effectively, right? So what we're doing is using our peptide fragments to train only those troops that are doing the bad thing, right? That are causing the friendly fire. And in this way, unlike the many other approaches that are being currently developed for autoimmunity, and particularly for MS, there are fantastic new drugs coming through, but they all cause serious side effects, right? Because if you suppress the immune response totally, you get infections, you get cancers arising, you get reactivation of Epstein-Barr virus that causes cancer. So by selectively going in and treating only the cells that cause the disease, by targeting only those cells, you can ameliorate the disease without any side effects. And that's what makes this approach so distinct from all the others. There is a nice analogy, and that is, this was a study that was done in Switzerland a number of years ago, where they wondered why beekeepers never suffered from bee stings. So they studied their immune response to the bee venom, right? And it turned out that they did respond to the bee venom in the winter months, right? But then when they started being stung, their immune system changed. So by injecting the bee venom through bee stings, their immune response to the bee venom was being switched off. They were becoming desensitized. There are biochemical changes in the cells that control that, and we figured out what those are. But it's really just a matter of switching off the T cells specifically. Well, I think the horizon is, all the implications of this are profound, and they're very, very extensive, because there are arguably 100 different autoimmune diseases, of the major autoimmune diseases, such as thyroid autoimmunity, Graves' disease, Hashimoto's disease, the joint diseases, rheumatoid arthritis, pancreas, type 1 diabetes. These are major problems in human health, and this approach can be applied to them all. Furthermore, it could be a more safe way of dealing with allergic disease, because you wouldn't run the risk of your therapy inducing the anaphylactic shock that can kill people with severe allergies. And we have, as I said, we've conducted 3 clinical trials in multiple sclerosis, and we're currently conducting another early stage clinical trial in Graves' disease, which is the thyroid disease, where the immune system activates the thyroid gland. And I think if that Graves' disease study shows efficacy, then what it will have done will have been to prove that the example of what we've done in multiple sclerosis extends to other diseases and would therefore be applicable to a very wide range of diseases.